Here we want to verify the trig identity. So we want to make sure either our left side can turn into our right or our right side can turn into the left. I find that the left side looks a little more crazy. So I'm going to start by playing with this. I see a tangent squared plus 1. Remember that sine squared x plus cosine squared x equals 1. So tangent squared I can create by dividing everything by cosine squared x. So that sine squared over cosine squared is tangent squared x plus 1 equals secant squared x. So I know that this numerator is secant squared y. So I'll have secant squared y, which is a good start because that's part of the answer here, over. Now sine is sine y, tangent is sine y over cosine y, and secant is 1 over cosine plus 1. So what I see here is now I have sine squared over cosine squared plus 1. So I have secant squared y over sine squared over cosine squared y plus 1. Well, sine squared over cosine squared is tangent squared. So I have secant squared y over tangent squared y plus 1. Well, secant squared y is tangent squared y plus 1. So this is secant squared y over secant squared y, which equals 1. Okay. Well, can we change this side to equal 1? Well, let's see. Well, this is 1 over cosine squared y minus sine squared y over cosine squared y using trig identities. Well, since they're the same denominator, that's 1 minus sine squared y over cosine squared y. Well, I know from my trig identity that 1 minus sine squared is cosine squared. And cosine squared over cosine squared equals 1. So both of these sides are equal to 1, therefore they are equal to each other.